Hello, welcome back to my channel. So today I'll be going over orbital notations, so that this is also part of electron configuration, so I like to think of it as a visual on how electrons are spinning. So this is just, I'm going to start off just as a reminder with each orbital, the s, p, d, and f orbital, and we have to know the number of orbitals of each, so that helps us figure out how to put the electrons in. So the s orbital has one orbital, so it'll make sense once I, draw all the blanks. So basically, I like to call it as rooms where to put the electrons in. And then we have the p orbital, which has 3. And then we have the d orbital, which has 5. And then we have the f orbital, which we won't really work with in this video, but you do have to know that it has 7 orbitals. So 1, 2, 3, 4, 5, 6, 7. So as a reminder, remember the number of orbitals means how many directions, number of ways that the electrons can orbit. So the s orbital has 1 orbital, but it can maximum electrons is 2. So each orbital can hold 2 electrons. So each blank can hold 2 electrons. All right. And so by electrons, I mean we're going to draw arrows to represent electrons. So first, I'm going to show you the steps on how to do the orbital notations. So the very first step you have to do is find the electron configuration first. You can't do orbital notation without the electron configuration. So find the electron. I'm abbreviating electron configuration. Again, I'm abbreviating first. If you don't know how to do that, then you can't do the orbital notation. You must do this step first. And then you have to draw the orbitals, which are the blanks here. And then you add arrows for the electrons, or the exponents in your electron configuration. So we're going to start with a simple example here. We're not going to do too long, but let's do nitrogen. The electron configuration isn't too long, so electron configuration for nitrogen, so you start from the beginning, 1s2, then 2s2, and then 2p3. Because in the second row, p block, third element, 2p3. Alright, so now we're going to use this to draw our orbitals. So we have first our 1s. So we have 1 orbital for the s, and we're going to label that as 1s. So think of it as the first floor, like in an apartment. And then we have 2s, and then since I don't really have room to draw actual floors, I'm just doing the same level, 2s. And then we have 2p. So p is the p orbital, so 2p has 3. So I'm going to give a little space here, 2p. Alright, so the letters pretty much tell us, like the s and the p tells us how many rooms or how many blanks we draw for the orbital. And now for the exponents, right here, that tells us the number of electrons. So 1s2, I have 2 electrons, or 2 arrows I'm going to draw on this blank. And we do up and down arrow. So the main rule for, and I'm going to have a separate video on the quantum theory rules, but we cannot draw electrons in the same direction. We have to do in opposite direction. So think of it as batteries. When you put in batteries in, any electronic or whatever, you don't put the batteries in the same direction. There's always a plus and minus sign, and you got to make sure that you put them in opposite directions. So same thing applies here. And now for 2s2, same thing, I have 2 electrons, like that. And then for 2p3, so here for the p orbital, it has a maximum of 6 electrons, right? However, we only have 3. So you got to make sure that you have to fill it in correctly. And again, that is a video on quantum theory rules, so you should go ahead and watch that. But basically, you have to fill it in like this. 1, 2, 3. All right. The reason why you fill it in like this, because you got to fill in all the orbitals before you come back and refill. So think of it as an apartment. let's say you have a 3-bed or like a 4-bedroom apartment, let's say, and there's 3 of you, right? Would you all bunk in the same room? No, each of you would have your own room, but then when you have someone else come into the apartment or the house, that's when you start bunking in and share rooms. So same thing applies here. All right, so let's do another example with aluminum. And the electron configuration for that. So actually pause the video, go ahead and try the electron configuration by yourself, and then play to see that you got it right. Alright, so you should get this as your electron configuration, and it's a bit longer, but again, same rules apply when drawing your orbital. So 1s2, I get 1 blank for 1s, 1 blank for 2s, 3 blanks for 2p, 1 blank for 3s, and then 3 blanks for 3p. And then again, you look at your exponents to figure out how many arrows you put down. Alright, so 1s2, 2s2, then 2p6. This works out because it fills in the entire orbital shell. And then 3s2, like that, and then 3p1. You have to put in, and it has to be in the first one. You can't just do any blank. You got to start the first one. All right. All right, so I'm going to show you the shorthand the shorthand orbital notation, because even though, even writing the whole longhand electron configurations is a little annoying, so do orbital notation. So there is a shorthand version for orbital notation. So calcium, if you look at the shorthand electron configuration, so calcium is right here. The noble gas that's before is argon. And then it's 4s2. Right? So to draw the the orbital notation for it is actually quite simple. It's actually kind of the same way as we did it. So instead of drawing all the things for argon, we simply just write argon like that, and then we draw 1 blank for 4s because it is the s orbital, and then it has 2 electrons, so up, down, and that's it. Alright, so I hope this helped. Again, you should go ahead and watch the quantum theory rules video that actually explains how we fill in the arrows in the orbitals and what's allowed and what's not allowed. But yeah, so I hope this helped. Thank you so much for watching, and have a great day.